Hello class, today we will be finishing up the final review for our Algebra 2 EOI. We're going to start with this question right here. Which expression is equivalent to 3/5 raised to the negative 4/7 power? Okay, we're going to pick up our calculator. We're going to go to a new document. We're going to add calculator. I'm going to go parentheses, control divide so I can get a fraction there. Move it over here, make sure I get the right 3/5, 3 on top, 5 on bottom. Finish my parentheses, caret, and I'm going to raise it to the negative 4 divided by 7 power. That's pretty crazy looking right there. Since that doesn't really give me the answer I'm looking for, we're going to go back to the sheet. So right here, this negative 4 power tells me that I need to switch everything in the inside, what's on bottom on top and on top on bottom. So I need to take the reciprocal. That's what the negative up here tells me. So I have 5/3 raised to the 4/7 power. Remember, I have power over index right here. So I have this to the 4th power raised to the with the 7th index. So I have the index as 7, and I have 5/3 power raised right here. This answer looks very similar to B right here. Whenever I have parentheses, the power goes to the numerator and to the denominator. So the number in the numerator is also raised to the 4th power. Likewise, the denominator is also raised to that 4th power. So I can rewrite this right here as the 7th root of 5 to the 4th over 3 to the 4th. Just like B looks right here. Second question. What is the simplified form of this expression? I have square roots right here, and I have a minus sign between them. I cannot add or subtract square roots or radicals that are not common bases. They don't have any common things inside. Well, I can make this look common. I have 17x on the left, and I have 68x on the right. 17 is a prime number, only 1 and 17 go into it, but let's look at 68. 68 has factors 2 and 34, and 34 has factors 2 and 17. I have a pair right here of 2's, so I can take those out of the radical sign. And remember, when I take a pair out of the radical sign, I multiply it to the coefficient in front. So this pair of 2's come out to multiply by 20, and I get 40. So let's write this down again. I have the square root of 17x minus 40 to the square root of what I have left over. I have 17 left over plus the x that I didn't use. Now I have common bases inside my radicals, 17x and 17x. The coefficient in front of the first square root of 17x is 1. 1 minus 40 is negative 39, and I have the 17x that I don't add, subtract, or I don't change. So my answer is F. Next question. What are the quotient and remainder when this division is performed? So I can rewrite this as x squared plus 1 divided by x to the 5th minus 2x to the 4th. Now pay attention here. Since I don't have an x cubed or an x squared, I have to have placeholders for them. And since I can't add any values to it, I have to put 0x cubed and 0x squared. Then 3x plus 7. Running out of room here, so I'm going to try to slide over here just a little bit. Okay. So I have to have placeholders there. Now I need to divide it. Whenever I use division, the whole point is to eliminate the first term. So what can I multiply by this first term to eliminate this first term? And I'm going to multiply it by x cubed. Then I multiply this term, x cubed, by x squared, and I get x to the 5th. and then I multiply x cubed by my second term, 1. 1 times x cubed is x cubed. Notice where I put the x cubed at, under the other x cubes. If I were to put x cubed right here, I can't subtract negative 2x to the fourth and x cubed. They don't have common factors. The 4 and the 3 are not the same. When I get to this point, I switch the signs and I add. This cancels exactly like I wanted it to. Then I just bring this term down, negative 2x to the fourth, and 0x cubed minus x cubed is negative 1 x cubed. Bring down my next term. I have 0x squared. Now I have to eliminate again my first term, and my first term down here is negative 2x to the fourth. So what multiplies to x squared to get negative 2x to the fourth? Obviously the negative 2, and I need 2 more x's. So I multiply just like I did at the first time with the x cubed. I multiply my negative 2x squared to x squared, then I multiply it to 1. So I get negative 2x squared. Negative 2x squared times 1 is negative 2x squared. If I do not eliminate this first term, I did it incorrectly. So now I change the signs and I add. First term cancels. This term wasn't eliminated, so I write it down. This term, negative or 0x squared plus 2x squared is plus 2x squared. Let's look over here at our answers and see if we can eliminate any answers so far. It asks, what are the quotient and remainder when the division is performed? The quotient up here is going to be our answer. So I need to find where I have answers x cubed and negative 2x squared in any of them. Right here I have the x cubed, just like it says, but then I have negative 3x squared. I don't have negative 2x squared like I want, so my answer isn't A. Likewise, my answer is not B. I have x cubed and negative 3x squared. Can't be B. Right here, C, I have 4x plus 5. That's not the quotient that it's giving me either. So I haven't even finished the problem, and I've already eliminated 3 of the 4 answers that I have. Let's finish it out. So now I bring down my next term, and I have plus 3x. What times x squared gives me negative 3x squared? Negative x. Don't worry about the 1. The 1 is being taken care of with this negative sign. There's already 2 x's up here, and I need 1 more, which is going to be x, exactly like I have right here. So that gives me negative 1x squared minus x. Change the signs and add. That gives me 2x squared plus 4x. And yes, the first term is canceled. And I bring down my next term, which is 7. Now I have to say what multiplies by this, x squared to get 2x squared. And yes, it's just 2. And I get, extend the page, I get 2x squared, and I get plus 2. When I change the signs and add, I get 4x plus 5. Since I can't bring down any more numbers up here at the top, that ends up being my remainder, exactly like it looks right there. Four, which expression is equivalent? This one's a little bit different because I have a fraction in the numerator inside of my entire fraction. So let's go ahead and factor this trinomial in the bottom. I have 1 over x minus 3 over, what are the factors of negative 6 that add to be negative 1? X minus 3, x plus 2. So now I've got to ask myself, how do I get rid of a fraction inside of a fraction? I multiply by the denominator. Since I have the fraction in the numerator, I'm going to multiply the top and the bottom by its denominator. The denominator right here is x minus 3. So I multiply the entire top by x minus 3. And then I multiply the bottom by x minus 3. Now, in essence, what I'm multiplying by is 1. Because x minus 3 divided by x minus 3 divide to be 1. Anything divided by itself is 1. So when I multiply this together, this is a fraction, which is x minus 3 over 1 multiplied here. So let's see what this looks like. That is x minus 3 over x minus 3 over, in the denominator, these three binomials multiplied together, which is x minus 3 times x plus 2 times x minus 3. If you look in the numerator right here, x minus 3 divided by x minus 3 divides off to be 1. And if you look in the denominator, x minus 3 and x minus 3, when you multiply two binomials together that are the same, I can rewrite that as x minus 3 squared, and then I have this x plus 2 added on, which looks a whole lot like letter H. Anytime you have a fraction inside of a fraction, you multiply by the denominator to get rid of it, by this denominator. And since I multiplied by a form of 1, I canceled it off. And that's what I'm looking to do. Next question. What is the product of 3 minus 5i and 2 plus 4i? Pick up your calculator and let's figure it out. Calculate, and I have 3 minus 5i, so I'm going to go parentheses, 3 minus 5. It is not the I down here that is in the keypad. I want to go to book. There's two ways how to do this. I can go to book, and I can make sure this number 4 is highlighted up here, make sure it doesn't have anything else, find the I, and it pops in there. Now, it says product. The operation of product is multiplication. So I'm going to put times, parentheses, and it's going to be 2 plus 4i. And I have 2 plus 4. Now the second way to find your I is over here on the far left. You have a pi button. Hit that pi button and up pops this box right here. And I'm going to hit the I. It's the same I as if you were to hit book. So you have the pi button down here that pops up I, and you have the book that pops up an I. Close the parentheses, hit enter. 26 plus 2i, which is D. If it asks to find the quotient, if it asks to add, if it asks to subtract, anything that has an I in it with these binomials, I'm able to do that by using the calculator. Next question. Find the value of f divided by g when x is negative 6. Normally we see this function notation as f divided by g of x, but now it is telling us to define this function when x is specifically x. So I'm going to take my two functions and I'm going to divide them. F is in the numerator, so I have x squared minus 49 over x squared plus 3x minus 18. Now, it tells us to define this where x is negative 6. It doesn't tell me anything about factoring this difference of squares, factoring this trinomial. It doesn't say anything about this. This basically says is take that negative 6 and plug it in for x. So that's what we're going to do. So right here, I'm going to have 6 squared minus 49 over 6 squared plus 3 times 6 minus 18. That's all I have. So I have 36 minus 49 over 36 plus 18 minus 18. When I plug that all in, I get negative 13 divided by 36. The 18s cancel off, and that's what I have. Next question. The graph shows y equals f of x. So this is the function that it tells you. It says this is y equals f of x. It doesn't tell you what the function is. It just says this is a function right here. And it says what is the function of f of negative 1? That's not good. So when the function notation, when I have it just like this, f to the negative 1 power, that stands for inverse. And we are trying to find the inverse of this function. These two functions are related by their inverse. And if you recall, inverses is where we take the domain and the range and we switch them. The domain goes to the range goes to the domain, which is basically my x and my y switching. The x goes where the y's are, the y's go where the x's are. Okay? A visual way of seeing this is to actually graph the y equals x line, y equals x. If I were to graph y equals x, that is a line, that is a 45-degree angle, just like this. And remember, we find where they reflect. So if this was a function right here, a exponential function, its inverse would be a logarithmic function going back this way right here. And they would be reflected about the xy line, this line right here. So we need to find where this function is reflected about the xy line right there. So let's just draw this function right here, where just kind of, this is actually a radical function, and it's just kind of veering off this way. So I'm going to start at 2, and I'm going to veer off that way. I'm going to start at 2, and I'm going to veer off that way. Start at 2, I'm going to veer off that way. Start at 2, I'm going to veer off that way. And I want to find where it looks like it is symmetric about the y equals x line. Okay? Well, it really doesn't look symmetric here at B. Cross B, not a B. It doesn't look symmetric here at C. It really doesn't even look symmetric at D. But it does look symmetric here at A. And I know my function is off just a little bit, but that's exactly where it's supposed to hit. Remember, it's symmetric about the y equals x axis, and if it y equals x line, and if it crosses the y equals x line, it's supposed to be relatively in the same spot. Now my drawing's off. It's really supposed to be in the exact same spot, which it looks just like here at A. It's reflected about the x equals y line, or y equals x line, and they cross at the same spot. Remember, the inverse is denoted by that little -1 at the top. Next question. Which graph represents the solution set to the system of the inequalities below? Pick up the calculator and we'll graph this. On new document, add graphs, and I'm going to, I'm going to see, this is y is less than, so y is less than, I can get it over here. Control divide 2 over 3 x plus 2, enter, and I can go tab, and I'm going to backspace so I can get the less than sign again, and I have control divide 2 over 3 x minus 1, enter, and I can see where these two lines, have that graph right? Yep. I can see where these two lines overlap. Now, where it's darker is where they actually overlap, the darker area. Okay, so let's go and look at some of my answers. Okay, so it doesn't look like F because it was all south of these two lines, and now it could be F because of the actual dotted lines. Remember, whenever it's less than or greater than, it's a dashed line, and when it's or equal to, it's a solid line. Okay, so it could be all of my answers. It can't be G because there was some answers down here south of the second one, so it can't be G, and it can't be F. Can't be J because this line right here doesn't have any shading going on at all. So the only one it can be is H. Use that calculator that has a lot of capabilities to it to your advantage. Okay. Next question. What is the solution set of this equation? So again, let's use the calculator. I'm going to go on, new document, save no, add graphs. I think you've heard me say that maybe once or twice. So it's set equal to 0. So automatically I'm going to graph it and see where it crosses the x-axis. So I have 9x squared plus 6x plus 1. Enter. Okay? That's all I got there. Can't really tell if it touches it once or touches it twice. So I'm going to zoom in. Zoom in right there where it seems to maybe cross. Okay? Doesn't seem like it crosses at all. I'm going to go menu, analyze graph for 0. I'm going to go to the left, and then I'm going to slide over and go to the right. That seems to be where it crosses at, -0 or 0.33333, which is -1/3, comma 0. Okay? And since I'm wanting to find my value of x in this equation, my value of x, I only have one point where it crossed the x-axis or touched it. The value where it showed right here at -1/3, comma 0, I'm wanting to find the value of x, not 0. Okay? So that's why D is my answer. Let's go to the next one. The height of a projectile, h of t, which is a function notation, which is just like f of x. Don't let h of t, x of y, a of b confuse you. That is function notation. F of x. Inside the parentheses is your x value. So just like here, it's x. This t right here is going to be x. This t right here is going to be x. So this function really is f of x equal to -32x squared plus 128x. Is modeled as a function of time t, which is x. T fits right where x would be. That is time x. In sections, how long is the projectile in the air? So what this is a parabola. A parabola that is upside down, being the negative. It's shifted up 128 units on the y-axis. And what this function is it starts right here at 0, 0, and it's going to go up and it's going to come down. We want to know how long that projectile is in the air. Okay? And it's going to be noted by wherever it crosses the x-axis right here. Flight time, it's going to go up. It's going to be traveling just like this. It's going to hit its maximum point, which that's not what it's wanting. It doesn't want to max, and then it's going to land right there. Okay? So let's go to my calculator. On, new document, save no, add graphs, and I have -32x squared plus 128x. Enter. And that's my function right there. Menu, analyze graph, and I just hit a maximum. Menu, analyze graph for 0. Lower bound is to the left, upper bound is to the right. That's exactly what I found. 4, 0, where x is 4, X is time. T stands for time. So my answer is H.